Alright, number one, we need to describe the transformations here. So to begin, we look if there's a number in front. In this case, we just have a negative that causes it to be a reflection. Generally a reflection over the x-axis. The plus 2 inside there, that's causing it to go left and right, in this case left 2. And the plus 1 back here at the end is going to cause it to shift up, in this case up 1. Alright, now to make the graph, you guys have seemed most happy about going and using your graphing calculator, so let me get a video of that going. Alright, so here goes our video here. Let's see. I'm going to go to y equals. I've got my function typed in. You can press graph. There's basically what we're supposed to get on paper, but we don't just want to stare at the graph with the calculator and try to sketch it. We want to go to the table, which would take us here, and I'm going to scroll backwards a little bit. This spot right here, -2, 1, is basically the start of the graph. So that's going to be a point on the graph. You can see this -1, 0. That's another nice point. The idea here is we're looking for nice numbers to go put on our graph. Generally we avoid the decimals. Obviously we avoid the errors. Here's another point, 2, -1, so you can put that dot on there. If I scroll down a little bit, there's 7, -2. Those are all good dots for our graph. Alright, so there's our table we got from the calculator, and here we go. So those are our dots in the graph. -2, 1, that's right in there. -1, 0. 2, -1. And 7, -2. And that's going to have to be good enough. Alright, so the domain and range. The domain is how far left and right a graph goes. Well, that's the x numbers, and in this case this graph kind of begins at x equals -2 and then goes right forever. So that would be said as x is greater than or equal to -2. The range is the y values, how far up and down the graph goes. In this case, the highest up that the graph goes is 1, and then it goes down forever. So I'm going to say y is less than or equal to 1, and that's the end of that problem. Alright, now we're going to do some function operations. Number one, we have to do f of x plus g of x. So that is going to look like this. X squared plus 5x minus 9 plus 2x minus 3. Essentially this is just combining like terms. So the x squared doesn't have anything to combine with, so I'm just going to write it. The 5x is going to combine with the 2x right there, so that makes a 7x. And then finally the minus 9 is going to go with the minus 3 back there. That's going to make a minus 12. And that's the end of that problem. Number two, we need to subtract those, so it's essentially the same thing. Same setup. It's just that we need a minus sign in between, which does make our math a little bit more challenging. So again, the x squared doesn't have anything to subtract with. You just write it. Now I'm going to do 5 minus 2 would be a positive 3, and the minus 9 minus a negative 3. That's a lot of minuses. -9 minus -3 is the same thing as -9 plus 3, so that's minus 6. That's the end of that problem. Number 3 is going to be a little bit longer. Let's see, f of x times g of x. That would look like this. X squared plus 5x minus 9, and then I'm going to multiply that times 2x minus 3. This problem feels probably a little bit backwards. You could just immediately start doing like a triple distribution thing. I think you guys will be happier if I reverse the order of that. That's going to seem more like what we've done in class on a regular basis. Honestly, it should end up the same either way. The idea here is I'm doing a large amount of distribution, so that would give me 2x cubed, 10x squared, and a minus 18x, and then I would go through and do these. And there we go. So now we've got a bunch of like terms to combine. 2x cubed does not have a partner, but this one and this one go together. That makes a 7x squared. We have a minus 18x and a minus 15x. I think that's negative 33. And finally the 27, and that's the end of that problem. Number 4 is f of x over g of x. There's really not a lot to say about that one. You just put x squared plus 5x minus 9. That's the f function right on top, and the g function on the bottom. And that is the end of that. That's done. All right. Number 1 of the ACT problems here. This is pretty much a traditional sort of Algebra 1E math problem with systems of equations. Now, I'm going to be honest, this is going to be kind of the long way of going about this. So when it says 2 candy bars, that's like 2x, and 2 bags of chips, that's like 2 times y, where x is the number, is the price of a candy bar, and y is the price of a potato chip bag, and that equals $4. At the same time, we've got 3 candy bars and 2 bags of chips costing us $4.75. So you will have no doubt seen problems kind of like that in Algebra 1, for example. Sometimes we review them in Algebra 2. I guess I'll go ahead and kind of finish that problem. You may have seen these before. You basically go through and you multiply everything here by -1. That would change the signs. And what happens here is that those cancel out, and I basically just do like a big plus problem here. That makes negative 1x equals negative 0.75, or in other words, x equals, if you divide both sides by -1, you get x equals 75 cents. So the cost of a candy bar is apparently 75 cents. Again, that's the very, very mathy algebra way of getting that. Turns out there was probably an easier way, because remember, the trick is noticing 2 candy bars, 2 bags of chips, and now suddenly somebody has 3 candy bars with 2 bags of chips. The bags of chips haven't changed. All that's changed is 1 candy bar, and you can see $4 jumped up to $4.75. So the point is, a candy bar costs 75 cents. So that would be the quick way of doing that. They know students are going to think about this because that's what your math teachers have taught you, but there's usually on the ACT problem sort of a shortcut of just thinking about it to get what you need. Unfortunately, that doesn't answer the problem. We still need to know what the price of a bag of potato chips is. So you still basically have to understand, if I'm going to buy 2 bags of chips at 75 cents each, that is $1.50 on candy bars. And if I spend $4 and $1.50 of that is on candy bars, then that means that $2.50 is on chips, and I've got 2 of those, so I divide that by 2 and I get $1.25. Again, the more mathy version of that is to snag this 75 cents and plug it back up in for x and solve for y. You're going to do all the same math, and you're going to end up with the same answer, $1.25. All right, this one's a little faster. In the following figure, the perimeter of the square is 20. That means the distance around the whole shape is 20. So since it's a square, they tell us that, we can simply take 20 divided by 4, and we get the side length of 5. So that means 5 here, 5 here. That basically means, remember, area is equal to the side squared, or length times width, which in this case would end up being 5 times 5, or 5 squared, 25. That's the point. Now, since they want half of that, we basically want half of 25. And you would get 12.5. just for the record, you might have also been thinking about doing the formula for a triangle. Maybe that's what first came to your mind. I'll just remind you, area of a triangle is 1/2 base times height. And essentially that results in the same thing. We just found out this is your base, and it's 5, and its height is also 5, and so 5 times 5, half that, you still get the same thing. So 1/2 of 5 times 5, same thing. So kind of two different ways of thinking about it.